Today we want to look at the translation of parabolas. And what that means is what happens if we have a parabola where the vertex is not 0, 0. Now, yesterday we looked at examples of our 4 types of parabolas, right? We can open left and right, up or down, and we had our 4 formulas here across the bottom, and notice the form they were in. So first let me say, if we have something like this, this is not in those forms. So I would need to rewrite this as y squared is 1/4 x. Now, right away, once it's in that form, I could look and say, okay, this is that form that I am working with right now. So that if I go back to my graph, I can say, all right, I know this parabola, the vertex is at 0, 0. I know my focus is right here, but I need to be able to find P. So I know this part in front is 4P equals 1/4. So if I divide by 4, that tells me my P is 1/16. And as we talked about yesterday, that means this would just be 1/16, 0. So there's my focus. And then my directrix would be this line back here, which would be x equals minus p, which is negative 1/16. And then if I draw my parabola, I'm not going to deal with the latus rectum right now and some of those kind of things, we can get to here. Okay. And if I wanted to graph my my axis of symmetry, my axis of symmetry is this line that goes right through the middle. So my axis would be y equals 0. Okay. So that's just kind of a review of everything we looked at yesterday. What we want to talk about today is what happens if this vertex is not at the origin. What if it's not at 0, 0? And to really understand this and do this, we really got to understand all that we looked at yesterday, because the same thing is going to imply. If I'm at my vertex here, I just go over P to get my focus. I go back P to get my directrix. So that if my vertex is not at the origin, but it's somewhere else, all that changes is what the vertex is, and I'm still going to go to the right P and to the left to the directrix to find my new point. So let's go through and see what we're talking about. So if we have this graph here, y squared 4px, that's what we just looked at, we know our vertex is 0, 0. We know this opens to the right. We know our focus is P0, and our directrix is x equals minus P, and our axis of symmetry is y equals 0. And that is all of what we had here. If I move these lines back to here, that's what we had in this example. But let's say we move the vertex. Let's say it's in now this form. And just like we've looked at with a lot of other things this year, my vertex is now HK. It still opens right. So let's look at a graph here. And let's say that now this is our vertex HK. Now, we know it opens to the right. So that still tells us that this distance here to the focus is P. Well, instead of just relying on the formulas, think about it a second. If I have this point and I move to this point, what's my focus going to be? It's not going to change the K. That stays the same. this point is just going to be h plus p. So that is my focus. H plus p, k. And you'll notice over here how this works. Really, this 0 becomes h, this 0 becomes k. So we have 0 plus p and k. We get the same kind of equation. Now, where would our directrix be? That's going to be the vertical line here. And the distance from here to here is p. So this line is just going to be h minus p. So there is our directrix. X equals h minus p. And once again, instead of relying on the formulas, draw a picture. And if I drew my parabola something like this, then my axis would be right through the middle, and that is just going to be y equals k. Just whatever my k is. So you notice all that happens is whatever my h is, whatever is with the x, just gets added to my vertex. H plus, H plus, H, and so forth. So we're doing the exact same thing. We've just moved the vertex. So let's look at an example. Find the equation of a parabola with the focus of 0, 2, and a directrix of y equals 4. What we want to do is draw a picture. So my focus is 0, 2, right there, and draw it again, and use my x for the focus. The directrix is y is 4, 3, 4. So right away the question becomes, which way does this open? Well, we know between my focus and my directrix, my vertex has to be right in the middle. So this is going to open something like this. So right away I know my vertex is 0, 3, and this opens down. So if you need to pull out your formula card or your formula sheet and look, if it opens down, we have x squared minus 4py. That's the form that this one is in. This is x squared minus 4py. So in terms of now moving this, this would be x minus h squared equals minus 4p y minus k. Well, my vertex is 0, 3. So my h is 0, my k is 3. So this is x minus 0 squared, y minus 3. I know my p value is the distance from my directrix to my focus, or directrix to my vertex is p, and the distance from my focus to my vertex is p. So that tells me that p is 1. So this formula is minus 4, because it's 4 times 1. So if I get rid of the 0, my equation is x squared equals minus 4 y minus 3. You can tell this is a function. It opens down, so the x is squared. And this really comes from drawing the picture, 1. That's your first most important step. 2, deciding which of those basic 4 function types is it, and then just substituting in your h and your k. Look at another one. First, draw a picture. My vertex is 2, 3. Right, this will be my h. This will be my k. And my directrix is negative 1. So right away, I can determine my P is 3. I don't even need to really find my focus. I know just from this is going to open to the right. Since this opens to the right, it's y squared is 4px is the basic equation. So this would be y minus k, y minus 3, squared, x minus 2. My p is 3 because that's the distance from the directrix to the vertex. And so this is 12, and there is my equation. So really, this is just a small step from what we did yesterday. We are just moving our vertex. And this really comes back to us understanding these 4 basic types. And from those 4 basic types, how do we move? From the vertex to the focus, from the vertex to the directrix, and using that information to come up with the equation of our parabola, not at 0, 0. All right, you are now ready for the homework over 10-2.